All right, we are lucky enough to be joined this morning by the man, the myth, the legend, Mike Randall. He is here from Wonders of Physics in the UW to tell us a little bit about magnets this morning. We're going to have some fun with science. Mike, thank you for joining us.
Man, myth, and legend. Boy, my wife will be
the legend.
My wife will
crack
up when she hears that.
I hope she's watching right now. I hope she heard that. All right, so we're talking about magnets today.
Yeah. So just to start off with, I'm going to have a little race here. So hang on to this tube. I'm going to take this ordinary-looking ball and just drop it through the tube, and that pretty much. You get what you expect, right?
Oh, Mike, that wasn't real exciting.
Ooh. But wait, I've got another one here. It looks just like that.
Okay.
We're going to try it again.
Okay. Oh, that one's much slower.
Much slower.
You don't have to be a physicist to tell that one was much slower.
Yeah, but you do need to be a physicist to know why.
Oh, so you're telling me I can't give the explanation? Okay, well, Mike, why was that slower?
Well, this is a piece of copper tube, and this is a magnet.
Okay.
Now, what do magnets like to stick to?
The opposite of themselves.
Refrigerators, right?
Refrigerators, sure.
Well, things that are made of iron or steel. Well, this is copper, so it clearly doesn't stick. And yet, when I drop this in here, there's something going on, right?
You're right. Okay.
Well, this is a little demonstration of something called Lenz's law. And to better show this, I've got another magnet over here.
Okay. Well, that one was even hard for you to pick up off the table. So this must be
it looks
powerful.
like wood. It's actually probably got some steel in there. Anyway, this is a channel of aluminum. Again, as we all know, magnets don't stick to aluminum, right?
Right.
So why does it do this?
It's sticking and slowly tumbling down.
Slowly tumbling down. This is an example, like I said, of Lenz's law. L-E-N-Z is the scientist who came up with this. It's basically a variation on Newton's third law. For every action, it's an equal and opposite reaction. Turns out when you move a magnet near a piece of conductive metal, it makes electricity flow.
Okay.
But when electricity flows in a piece of metal, it makes a magnetic field, which it turns out opposes the original magnetic field that started the whole thing. So the two things fight each other, and it slows down the motion.
All right,
okay? So it opposes that. So that's why the ball dropped through this so slowly, and why this thing tumbles down so very slowly,
because that magnetic field was formed, and they were fighting one another.
Right, so it was actually generating, it's like little currents of electricity that acted like little electromagnets that were holding the magnet back.
They got into a tussle.
Yes, scientifically speaking, it's a scientific tussle.
That's a very technical term.
This is an entirely different thing. This is a great example of nanotechnology.
Now this looks like, I mean, if you're just looking at it, it looks like motor oil. It doesn't appear like there's a whole lot to it.
Looks just like motor oil.
All right, we got a close-up of it right now.
So nothing special about this, but what it is, this is an example of nanotechnology. I don't know if you folks at home can see that so well, but
just hold it right there. They're gonna push in on it.
This is called ferrofluid, and it's made of a liquid that's got little tiny nanoparticles of a magnetic material in it. And when you put a magnetic field near it, everything kind of lines up. And so you can actually see the shape of the magnetic field. So I've got a big magnet underneath here. So there's another example of it here. I know probably not the best television here because it is kind of hard to see a black liquid.
No, we can see it. We can tell. There it is.
So there you can kind of see it there. So this is very weird stuff and very useful stuff as it turns out. Other than just showing people what a magnetic field looks like. You'll see this used in all kinds of things. They have medical uses for it. They've got it actually used in loudspeakers and hard disk drives, all kinds of things.
So even things that people are using today.
Yeah, chances are you've got some of this fluid in some appliance you have at home.
Okay.
But I like it just because it's really fun and amazing. And
it's just neat to play with.
It's very fun to play with. And yes, there are executive toys based on this stuff too.
I think I've seen a couple of those, yeah.
So these are just a few examples of how magnetism, there's some weird things going on with magnetism, and yet it does show up in our lives. For example, this Lenz's law thing, a variation of that is used in coin-operated machines. To separate real different types of coins because they're made of different kinds of metals, they'll fall different rates.
All right, Mike, we appreciate it as always. Thank you so much for joining us, and I hope that you at home, I hope that you learned something.
One quick plug.
One plug? Yes, go for it. Plug something.
Next month, or in April, early April, we've got our Science Expeditions, the big science festival on campus. It's the first weekend of April.
Okay.
Visit science.wisc.edu for more information.
All right, we appreciate it. As always, Mike, thank you so much for showing up.